All right, so for the 2013 free response question number 1, they're giving you a situation where unprocessed gravel is arriving to this processing plant, okay? And we also know that's G of T. That's the rate at which it's arriving, okay? And it's in tons per hour. We know the plant starts with 500 tons of unprocessed gravel. And then we also know that it's processing it, so it's removing. So this is a rate and accumulation problem, and it's an in and out problem because what's coming in is the unprocessed, okay, and they're giving you a function they're telling you the rate at which it's arriving, and they're also removing it, right? So this is the out part, the 100 tons per hour, okay? And this is the amount we start with. Now notice the difference. This is tons per hour, this is tons per hour, that's rate, that's a derivative, right? This is the amount, okay, 500 tons. So it's not a rate, it's just the amount, okay? All right, so for question A is G prime of 5. Using correct units, interpret your answer in the context of this problem, okay? And we can use a graphing calculator on this, okay? So I'm gonna grab my graphing calculator and my piece of paper and we'll start answering this. All right, so what I'm gonna do is I'm gonna find, I need to, excuse me, find G prime of 5, and then we're gonna interpret this, okay? So I'm gonna go to my graphing calculator and I'm gonna put this into my calculator and find it. So we wanna press Y equals from our home screen and clear out any functions that we have. And then we wanna type in the function 90 plus 45 cosine of x squared, which would be in this, well, x squared, which is actually t squared, right? Over 18. And come out of the denominator and close the parenthesis. Okay, so I'm going to go back now instead of having to type this in, and just double check to make sure you typed it in correctly, okay, now instead of having to type this out, we can just take the derivative of y sub 1, okay? So we want to find the derivative at 5, okay? So we're going to press alpha window, and then we're going to select number 3, and we want to take the derivative with respect to x of y1, so that's alpha trace, and then number 1, y1, and we want to find this at 5. So it gives us negative 24.5875, so the 5 makes the 7 and 8. Okay, so I'm going to go back to my paper and I'm going to record this. Okay, so G prime of 5 is negative 24.588. Now, G of T was a rate. So this is telling you that that rate is decreasing at T equals 5. So that's going to be the interpretation, okay? So we need to say this. You need to say it because it's happening at a moment in time. So at T equals 5, the rate at which the unprocessed gravel is arriving at the plant is, and because it's negative, we're going to say decreasing, .588 tons per hour per hour. Okay, and so now another way you could write this, okay, is tons per hour squared, okay, because tons per hour is tons per hour squared, okay? All right, so that's the answer to part A. So G of T is the rate at which the gravel's arriving, okay? And so for part B, they're saying find the total amount of unprocessed gravel that arrives, okay? Not the amount of unprocessed gravel at the plant, but how much unprocessed gravel has arrived during the hours of operation on this workday. Okay, so that's going to be an integral, okay, of G of T, because if we integrate this, that's going to give us the amount of gravel that's arrived at the plant, okay? So we'll do that. So this is going to be the integral from 0 to 8 of G of T dt, okay? And we're going 0 to 8 because that's the hours of operation for the plant, okay? So I'm going to go to the graphing calculator and I'm going to put this in. Okay, so what we want to do is press alpha window and we want to select number 4, function integrate, and we want to go from 0 to 8. And then our G of T function, which is the same as y1. So to get y1, we press alpha, trace, and then number 1. Then we want to take the integral with respect to x. And there we go. So 825.551. Okay, I'll go back to the paper and I'm going to record this. Okay, so this integral is approximately 825.551, and this would be tons, because the G of T is tons per hour, and dt, remember our T units are hours, so this is tons per hour times hours, which would give us the tons, okay? All right, so let's go to part C. So for part C, is the amount of unprocessed gravel at the plant increasing or decreasing at time t equals 5? Okay, so we have to think about this. G of T is the amount of unprocessed gravel that's arriving. So this amount of unprocessed gravel at the plant is not G of T, okay? It's actually a combination of the rate at which it's accumulating, which is G of T, but it's also being processed. So it's coming in, right? The gravel, okay, is coming in, but it's also being removed, okay? So we want to look at a combination of rates, okay? We want to look at G of T and also this other one it's being processed at a rate of 100 tons per hour. So that's a constant rate, okay? So let's go to I'm going to go to my paper and then we're going to answer this, okay? So for part C, okay, we got to look at the derivative of the amount of unprocessed gravel, okay? And the derivative would be G of 5, okay? So that's the rate at which it's coming in at 5, okay? And then minus 100, okay? And we want to see what that value is. If this value is positive, then this would be increasing. If this value is negative, then it would be decreasing, okay? Because these are my rates, okay, at which the unprocessed gravel is arriving and the rate at which the gravel is being processed through the plant. Okay, so I'm going to go to my calculator. We're going to put this in and see what number this gives us. So I want to go into and put 5 into my y1. So alpha trace for y1. So y1 of 5, that's G of 5. Okay, and then minus 100. And press enter, and we get negative 1.859. So I'm going to go back to my paper and record this. So this is equivalent to negative 1.859, okay? And then, all right, so what this means is, which of these is bigger, right? This one's gonna have to be smaller than this one, right? So what this means is, because this rate came out to be negative, the amount of unprocessed gravel at the plant is decreasing at t equals 5, okay? So we would say the amount of unprocessed gravel at the plant is decreasing at t equals 5. So we need to include this at t equals 5 because G of T, not G of T, whoops, G of 5, right? G of 5. G of 5 minus 100 is less than 0, okay? Because it's negative, that's telling me it's decreasing at t equals 5, okay? So now let's go to part D. All right, so for part D, what is the maximum amount of unprocessed gravel at the plant during the hours of operation on this workday? Justify our answer, okay? So one of the big things here is that, all right, we're maximum, right? Maximum amount. So maximum amount, that's gonna mean absolute maximum, all right? And if you look up here, okay, the hours of operation, that's a closed interval, right? So this is a closed interval. So to see the maximum amount, we're going to need to check our endpoints, and we're also going to need to check our critical points, okay? So we have to come up with an equation for the amount of unprocessed gravel, okay? So we're going to do that next, okay? So let's go to our paper. Okay, so to come up with the amount, I'm going to call it A of T. Okay, so the amount of unprocessed gravel at the plant. Okay, so we know from the very beginning of the problem that we started with 500 tons. So we got to start with that 500 plus, okay, and then we're going to have an integral, and it's going to be from 0 to T. Okay, and we gotta get the amount that has arrived minus the amount that's been processed. Okay, so that's an integral for g of x minus 100, and I'm going to put parentheses around that, and then dx. You wouldn't have to have these outside parentheses. Okay, all right. And so this is a function that would give me the amount of unprocessed gravel at the plant. Okay, so we need to find critical values, right? So we know we're gonna test t equals 0 and t equals 8, but critical values. I got to figure out where the derivative of this is going to be 0. So we have to look at what is a prime of t. Okay, so a prime of t is, this would be 0. Well, it would be just g of t minus 100. Okay, that's the fundamental theorem of calculus, right? If we take the derivative of an integral, we just put this value in here, right? Okay, so g of t minus 100. Okay, and what we have to do is figure out where this is equal to 0. Okay, so where is g of t minus 100 equal to 0? And we're only looking 0 is less than or equal to t less than or equal to 8. Okay, so we're only going to look on that interval. Okay, so we're going to go to our graphing calculator. We're going to solve this graphically. Okay, all right, and so let's go to our graphing calculator. Okay, if we go to y equals on our graphing calculator, this is g of t, right? So what we need to do is, to get a prime of t, what we need to come over here and do is subtract 100. Okay, all right, so then what we're going to do is, okay, we're going to go to our window, and we want this to be really between 0 and 8, because that's all we're looking for. So 0 and 8. And x scale I would keep out as 1. Let's just try this. I mean, mine was already at -3 to 3 for y min, y max. Let's just see what happens, because really you don't know what the height of this might be, okay? And we're not quite high enough, huh? Okay, so let's go back. And well, you know what? You actually could. I should go back to y equals. Sorry about this. I should put y2 as being equal to 0. Okay, because we need to use that to solve it. Okay, so back to this window. I'm gonna change this to what was our g(t) function? It was 90 plus 45, right? So I'm gonna move it up to like a 150. Okay, so negative 150 to 150, and I think that will be about right. And it's because of the cosine function, and it's 90 plus 45 cosine, right? That's why I'm figuring 150. All right, now let's go to graph. Okay, so there we see it, right? And actually 150 was too much, right? So right here, okay, we've got to find this intersection, and then we're going to want to store this, okay? So this is where the derivative of a of t is 0, okay? And that's going to be a critical number, okay? So we go to second, calc for trace, and intersect, and just enter, and then guess, just we got to be close, right? So it's this number right here, 4.923, okay? So I'm going to go back to the home screen. Okay. And we're going to take our X and we're going to store it as alpha. And I'm going to call it A because it was our first one. And there it is, right? The 4.92. Okay. So you can write on your paper 4.923, but in any calculation, you want to use the full number, okay? All right. Okay, so I'm going to go back to our paper, okay? And we're going to figure out where the maximum happens, okay? We're going to have to come back to the calculator again to do some calculations though. Okay? Okay, so we solved this, right? And we got T is about 4.923. Okay. And then so what we're going to have to do is we're going to have to find A of 0. Okay. A of 4.923. Now we're not putting 4.923. We're putting the whole thing in. Okay. And then we need to find A of 8. Okay. All right, so A of 0, we actually already know because if we take the integral, right, from 0 to 0, this is going to be 0. So it's just the 500, right? Plus, that's the amount that we started with, right? Okay, and then A of 8 would be 500 plus the integral from 0 to 8, okay? So we're going to need to put this into our calculator, this one and this one, to figure out what the values are. And let me slide this up a little bit. Sorry, you guys didn't see it. Okay, let me tear this off. Okay, so let me slide it up a little bit. That's what I had written. Okay, so A of 0 is 500, A of 4.923, and A of 8 is equal to this, okay? All right, so I'm gonna go to my graphing calculator and I'm gonna put these in. Okay, so we had changed earlier, we had changed our Y1, okay? And so we need to go back, we need to take out this 100, okay? Or leave it as y1 and we just integrate. This is the integrand. This is the thing that we're integrating. So you could do it a couple ways, okay? That's the thing that I'm going to need to integrate. I'm just going to go ahead and delete it, so I'm typing it in exactly the same way that I wrote it on our paper, okay? All right, so this is our g of t function, right? Okay, so we're going to go back to our home screen, okay? And we want to take the 500 and we want to add the integral, so alpha window number 4 for function integrate, okay, from 0 to alpha a, okay, and then it's our g of t function, right? So that's why we need to take that out, okay, that minus 100 from the y1. Okay, so we're going to take alpha, trace y1, and then minus 100, and then dx, okay? And we press enter, and this is the amount. So, okay, so that's the amount of unprocessed gravel at t equals 4.923, okay? Now we need to do it at the end of the day, right? At the end of 8 hours. So we're going to take 500 plus, actually, you know what? I'm going to delete this. We could just go up, it'd be quicker. Let me show you something. We can do this quicker. Let's delete that. Okay, we can just go up here on top of this and press enter. And there it is again, right? So that's the way to copy and paste. Okay, because we just need to change the A to an 8. Okay, so 525.551. So that's the end of 8 hours, right? So I'm going to go back and record these, okay, on my paper, okay? Okay, so on our paper, this amount was 600 at A of 4.923 was 635.376. Okay, and after 8 hours, it was 525.551. So this is the candidates test, right? We did the critical numbers, we did the endpoints, and then we just look which one's the largest, right? And it's this one, right? So the maximum amount of unprocessed gravel, because that was the question, right? The maximum, they're asking you for the maximum amount of unprocessed gravel. Okay, let me get my paper. Gravel at the plant is 635.376, and this would be in tons. Okay, at T equals 4.923 hours. Okay. All right. And that's the maximum amount of unprocessed gravel for the plant. Okay. And that's 2013 number B. Okay. And we finished it. All right. Hopefully you guys start to realize, okay, wait, this was a lot like that snow and the driveway problem, right? And that's what I'm trying to get you to understand is like, okay, these are related. Yeah, it's a different scenario, but it's an in and an out, right? You're adding and you're removing, okay? And just the more of these you see, the better we're going to get at it, okay? Because I'm very confident they're going to ask ask a rate and accumulation problem. They always do, okay? For both the BC and the AB students, okay? All right? Okay, so we're going to do the next question, okay? All right, and I'll go to that one. So for the 2012 BC question number 5, it's talking about the rate at which a baby bird gains weight is proportional to the difference between its adult weight and its current weight. So that's the 100 minus W. This is the adult weight, and B is the current weight, all right? And the rate at which it gains weight is proportional. That means this difference is multiplied by some constant, and that constant here is 1/5. Okay, you don't have to know all that for the calculus, okay? But that's what this is saying, okay? And then at time t equals 0, when the bird is first weighed, it weighed 20 grams. So we know initially at t equals 0, 0 days, 20 grams. B of t is the weight of the bird in grams, and time is t days after it was first weighed, okay? So we know B of 0 is equal to 20. That's from this, okay? This is the rate at which the bird's weight is either increasing or decreasing, okay? Depending on if this is positive or negative, okay? So the question A is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? So the rate is dependent upon the rate at which the bird is gaining weight depends on his weight, right? That's what this is saying. So we just got to put these numbers in and see which one's the biggest, okay? That's all we have to do. So I'm going to go to my paper and I'm going to do that, okay? Okay, so what I need to find is dB dt at, and it's a weight, right? So it's going to be B at B equals 40. So that's equivalent to 1/5 times 100 minus 40. And so that'd be 1/5 times 60. And 1/5 of 60 is 12. Okay, so this would be 12 grams per day. Okay, that would be the units for this. Because the units for B is grams and the unit for T is days, okay? All right, so we need to also find dB dt at the weight of 70 grams. Okay, so that's going to equal 1/5 times 100 minus 70. That would be 1/5 times 30. Okay, and then 1/5 of 30 is 6 grams per day. Okay, so the question was asking us, okay, is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams, okay? So the bird is gaining weight faster when it weighs 40 grams. This should be an S, okay? When it weighs 40 grams. Okay, why? Because, and what were we doing? We were comparing these two, right? So this one was bigger than this one, all right? So because dB dt at b equals 40 is greater than dB over dt at b equals 70. Okay, and that's part A. Okay, so let's go on to part B. Okay, so for part B is find, it says find the second derivative of B with respect to time for the second time in terms of B. Okay, so let's just do that first. Let's just do that first sentence, and let's worry about that, and then we'll go to the second part of the question. Okay, so I'm going to go do that. Okay, so to do this, I'm taking the derivative with respect to time of both sides, and this is the proper notation for it. And the derivative with respect to time of, and this one is 1/5 times 100 minus b. Okay, so this is where the notation comes in, right? It's the second derivative. So d2 of b, dt for the second time. Okay, and then what I would do is I would distribute the 1/5, I think. Okay, so this is d dt, and 1/5 of 100 is 20. So this would be 20 minus 1/5 b. Okay, so then that would mean the derivative with respect to time of 20 would be 0. Okay, and so this would be negative 1/5, and then we're taking the derivative of b with respect to time, so that'd be dB dt. Okay, so the second derivative is negative 1/5 dB dt, but we need this in terms of b, right? That's what they said. Okay, so I'm gonna slide this up a little bit. Okay, so this makes this equal to negative 1/5 times, and dB dt is 1/5 times 100 minus b. Okay, so that'd be negative 1/25 times 100 minus b. And that's the second derivative with respect to time. Okay. All right, so let's go to the next part of this question. Okay, so back to the question. Use the second derivative to explain why the graph of b cannot resemble the following graph. Okay. All right, so what we got for the second derivative is negative 125, 100 minus b. Now, b is the weight of the bird, right? So that's these values right here, right? So between 20 and 100, right? That's the weight of the bird. This is b, and this is t, okay? Or b of t, okay? So this second derivative, my bird's weight is somewhere between 20 and 100, okay? When I do 20, when b is 20 to 100, right? This is either gonna be a positive value or it's gonna be 0, right? When it's 100, okay? That means the second derivative is always going to be negative in here, okay? So what does that mean in terms of b, the graph of b of t? That would mean it's always concave down, right? Because the second derivative is going to be negative, okay? But what do we see on the graph? This graph right here, this part right here is clearly concave up, right? And this part's concave down. That can't happen if this is the second derivative. The between 20 and 100 for b, it always has to be concave down. So it'd have to look like this from 20 to b, or some curvature where it's curving down, where it's concave down. Okay, so there's no way this could be the graph of it. Okay, so how do you write that up, right? That's the big thing, is like, how do you explain that to somebody? Okay, all right, so let me go back to the paper and we'll do the write-up. I'm gonna need to slide this up a little bit. Okay, let me tear this off. Okay, let's keep the b there. Okay, all right, so for 20 less than or equal to b less than 100, right? I know this part's going to be positive and this constant right here is negative. So that's going to make the second derivative negative. Okay, for 20 less than or equal to b less than 100, the second derivative of b with respect to t for the second time would have to be less than 0, and the graph of B of t would have to be concave down for 20 less than or equal to b less than 100. For these b values, it would have to be concave down, okay? Clearly, the graph given is both concave up and concave down on different intervals. Therefore, the graph could not be, can't spell, my mind goes faster than my hand, okay? Could not be the graph of B of t. Okay, let me slide that up so you can see it. And there's different ways. I mean, this is just the way I thought of right now, okay? But it does have to do with concavity, okay? You might be able to do the wording a little bit different, okay? But basically, you have to establish that the second derivative. What you have to show the graders is that the second derivative is going to be negative, right? And clearly, the graph shows that it's that, and negative. Sorry, back up, okay? You have to establish that the second derivative is going to be negative, which would mean the graph is always going to be concave down. And basically the graph is both concave up on certain intervals and concave down, and that can't happen, okay? So basically you have to establish that, okay? All right, so let's go to part C. I think part C is going to be probably the easiest part of this, okay? Well, no, part A is probably the easiest, okay? All right, so let me go to that. Okay, so part C. Okay, so right off the get-go, what I'm going to do is I'm going to multiply both sides by dt, okay? And I'm going to tell you this, you don't want to distribute this, okay? And here's why you don't want to distribute the 1/5, okay? Is because to do separation of variables, you need a product. You have to have a product. And if you distribute this, you're going to get 20 minus 1/5 b, and then there's no way, okay, there's no way to separate the variables and get dt's and b's on separate sides, okay? That's going to be impossible for you to do, okay? So we want to multiply both sides by dt, okay? So that would give us db is equal to 1/5 times 100 minus b dt. Okay, so what do we want to divide? We want to divide by 100 minus b, because that will get me my b's all on one side, okay? All right, you can't, if you have addition and subtraction on a differential equation, that is a very, very difficult differential equation to solve. It's beyond the scope of what calculus is even. That's where you take a class on just differential equations, okay? Because there's other techniques, okay? So it has to be a product, okay? All right, so here we go. So we're going to separate this. So I'm going to multiply both sides by 1/100 minus b. So 1/100 minus b is equal to, and then db, whoops, db is equal to 1/5 dt. Okay, now we want to integrate both sides. So 1/100 minus b db is equal to the integral of 1/5 dt. Okay, so you could use integration by substitution here, okay, and let this be 100 minus b, let that be your u, okay? Now, if that happens, okay, then let's just go to show you, okay, nah, not du. In my head, I was thinking du, because I was already working ahead of the problem, okay? So u is equal to 100 minus b, and then du would equal negative db over dt, right? So we would need a negative with this, right? But to get that, I need a negative out here, okay? So some of you might be able to do this in your head. Oh, I knew there was going to have to be a negative, and then it's going to be the natural log of the absolute value of 100 minus b. That's a lot for you to understand right now if you're not understanding it, okay? If you're not understanding what I just said, then use the u substitution, okay? There's nothing wrong with it, okay? So we're going to get negative the integral of 1 over 100 minus b db, and that's equal to the integral of 1/5 dt. Oops, and I need to have this be a negative right here, right? So negative db, okay, because we're multiplying by it. So that's why I need parentheses, okay? All right, so this is going to become my du. This is going to be 1 over u. So I have negative integral of 1 over u du is equal to the integral of 1/5 dt. Okay, so this is negative, and this would be the natural log of the absolute value of u is equal to, and then this would be 1/5 t, not dt, plus c, plus your constant c, okay? And then the u goes back to 100 minus b. So negative natural log of the absolute value of 100 minus b is equal to 1/5 t plus c, okay? All right, so at this point, okay, what you can do is a couple things. We know that b of 0 is equal to 20, right? Because they said that, all right? I'm gonna slide this up a little bit too, okay? So you could start solving for b, or you can get your c right now, okay? It's really completely, totally up to you, okay? I am going to I'm going to solve for b first. Okay, that's just the way I like to do it. But you could do it either way. You could plug the 0 in for t and the 20 in for b, and you'd have your c. Okay, and that would be totally okay. Okay, so what I want to do next is I want to multiply both sides by -1. I want to get rid of this negative right here. Okay, so that's going to be the natural log of the absolute value of 100 minus b is equal to, and this is going to be -1/5 t, okay, and then plus a negative c now, right? But really, that's just still plus c, okay? Whether it's positive or negative will be taken care of, okay? So it's still just a constant. So we can just still put plus c because we don't know if c is positive or negative now, okay? All right, so then the next thing you're going to want to do is I'm going to want to integrate, or not integrate, we already did that. I want to exponentiate using base e, okay? So e to the natural log of the absolute value of 100 minus b is equal to e to the -1/5 t plus c, okay? So these are going to undo each other, and you're going to be left with the absolute value of 100 minus b is equal to, okay, we're adding here, right? So since we're adding here, that means we have two bases that are the same. So we have e to the -1/5 t times e to the c. And when you have e to the c, that's where I've always said, okay, let that be a different variable, okay? I'm gonna change it up on you. I've been using k all the time. I'm gonna use a. So let a equal e to the c, okay? So that means we have the absolute value of 100 minus b is equal to e to the -1/5 t times a. Okay, so now what I'm going to do is I'm going to put my numbers in now for b and t because I know b of 0 is equal to 20. So I'm going to put 20 in for b. So that would be the absolute. Let's just go ahead and do it. 100 minus 20 would be 80, right? So this is going to be 80, or absolute value of 80, which is 80. I should just say 80. is equal to, this is going to be e to the 0, right? E to the 0, because t is 0. So e to the 0 is going to be 1 times a. So a is 80. Okay, so now back over here, we have the absolute value. Actually, I'm going to slide up. Okay. There we go. Okay, so you can see the whole thing. Okay, so back up here, okay, I'm going to say the absolute value of 100 minus b is equal to, and instead of e times a, I'm going to write a times this, okay? So a is 80 now, so that'd be 80 e to the negative 1/5 times t, right? Okay, so now what does this mean? Okay, so what we can do is the absolute value, this is an absolute value equation. This could be positive or negative 80, right? E to the negative 1/5. So we have 100 minus b is equal to plus or minus 80 e to the negative 1/5 times t. Okay, now moving this over, okay, this is going to be b over here on this side. I'm just going to move it over to the other side. I'm going to move this over. So this positive is going to be negative and the negative is going to be positive. It's still plus or minus. So this is 100 plus or minus 80 e to the negative 1/5 times t is equal to b. Okay, now that's two choices, right? So b is either equal to 100 plus 80 e to the negative 1/5 times t, or b is equal to 100 minus 80 e to the negative 1/5 times t, right? Which one is it, right? Well, what do we know? If we put 0 in for t, we have to get 20 out. If we, in this one, if we put 0 in for t, that'd be e to the 0, right? Okay, and then that e to the 0 is 1, and then 80 times 1 is 80. This would actually give you 180, right? Okay, so when t equals 0, this one would give you b is equal to 180 grams, okay? Well, no, it's not supposed to be 180 grams. It's supposed to be 20 grams, right? So over here, when t equals 0, all right, we would get b is equal to, and it'd be 100 minus 80, and this would be e to the 0, right? And e to the 0 is 1, so this would be 100 minus 80, so this would be 20. That's the correct one, right? So let's cross this one out, okay, because that's the check, right? Which one is it? It's got to be this one. So our function is b is equal to, or b of t. We could write, you could write b also, okay? So I don't even think that's wrong, okay? B of t is equal to 100 minus 80 e to the negative 1/5 times t. Now you could rewrite this as b of t is equal to 100 minus 80 over, because it's a negative exponent, e to the 1/5 t. And either way is right, okay? If you wrote this, it's right. If you wrote this, it's right. Both are right, okay? And that's the 2012 exam, or 2012 question 5 solution, okay? All right, hopefully this is starting to catch on, and we've only done 2 of these, right? And it's starting to catch on. Okay, so that's it for today. Check your solutions. Make sure you're correcting them with a different color, please. Okay, and it's okay to get these wrong. It's okay. Like even if you messed up this and you're close, okay? Because the more you do, the better you get. The more you do, the better you get. All right. All right. So let me just encourage you. Okay, just hang in there. And I'm going to start doing office hours so that you guys can come and bring questions if you have any questions, and we can answer them together. Okay. So I'm going to start doing that probably next week. Okay. All right, guys, you take care. See you later. Bye.